Today's Scientific Eye is all about elephants.
Psst.
What?
Come here.
What?
Come here a minute. It's not about elephants. It's about elements. Have another go.
Today's Scientific Eye is about elements. Was that all right?
Yeah, it's much better.
I'm sorry about the elephant.
That's all right. Don't worry about that.
Elements are the basic building blocks of everything. People, buildings, the earth and everything on it is made up of elements.
The relevance of elements is everything to elephants. Like elephants, the elements are everything to you. Because there's elements in everything, in every single look. The chocolate bar, the diamond ring, the pen, the ink, the book. Your teeth are made of calcium, there's silicon in your chips. When it's dinner time, it's elements you place between your lips. The moon, the stars, the planets, the chewing gum you chew, the graphite in pencils, they're in your teacher too. The relevance of elements is everything to elephants. Like elephants, the elements are everything to you. There's oxygen, it's in the air. There's tungsten in the lights, aluminium in skin cream, and lead in water pipes. There's copper in the wiring. There's chlorine in the pool. There's elements in red hot chili peppers. Yet elements are cool.
Our whole planet is made up of just over 100 different elements. 3/4 of them are metals, like gold, silver, copper and iron. But if so much of the Earth is made of metal, why don't you find solid lumps of the stuff lying around in the soil? Well, sometimes you do. These tiny pieces of gold were found in the sediment at the bottom of a river. Gold is very unreactive, so it's found in the ground as pure metal. Sometimes it gets washed into rivers and mixes with the muddy sediments. A few enthusiasts know just where to look for it. Panning for gold takes skill and practice. The sediment from the river is sifted several times. Gold is heavy, so it stays put, and a trained eye will easily spot it. But he's hardly going to get rich on this tidgy amount. Finding pure metal like this in the ground is rare. Most metals are combined with other elements in the Earth's crust to form rocks.
This is malachite and it contains the element copper, and this is pure copper metal. For thousands of years people have known how to extract this metal from the rock.
Malachite, otherwise known as copper ore, is found in the ground. This mine here at the Great Orme in Llandudno dates back to the Bronze Age, a time when copper was used for making tools and weapons.
But first you need to find some malachite.
Underground there are over 6 kilometres of narrow tunnels.
Where I'm walking now was originally a vein of green malachite. It was dug out by people over 4,000 years ago, leaving behind a maze of passages and chambers. So just imagine this whole cavern was once filled with copper ore.
The first miners used large stones to dig out pieces of the precious green rock. Malachite isn't just one element, it's made of several. As well as copper, it contains carbon, oxygen and hydrogen.
To extract the copper from the rock, you need to get rid of all the other elements, and that's done by a process known as smelting.
First, the malachite is crushed, then it's placed in a crucible ready for heating. In the Bronze Age, copper ore was smelted in a small furnace made of clay. It reaches temperatures as high as 1,000 degrees Celsius. Of course, they didn't know that in the Bronze Age. They just knew it had to be very hot. Air pumped in through bellows helps the furnace reach the right temperature. Then, in goes the crucible and it's covered with charcoal. The charcoal reacts with all the other elements in the malachite, leaving behind the copper. And the result, liquid copper, an element. Once the copper has been extracted, it can be poured into a stone mould. It quickly solidifies and begins to take on the shape of an axe head. Its beauty and durability make copper a highly prized element. Today, copper ore is mined on a huge scale and smelted in massive furnaces. Copper metal is used for all sorts of everyday items, like water pipes, coins, and copper wire. Tin is another metal element which can be extracted from rock. This is a lump of tin ore. As well as tin, it contains oxygen. Smelt it, and once again, the pure metal is left behind. Copper and tin are both elements, so what's the difference between one element and another? Copper and tin are made up of particles called atoms. In pure copper, all the atoms are the same as each other. It's the same with tin, but tin atoms are bigger. A pure element is made of just one type of atom. The idea of the atom goes back as far as the ancient Greek philosophers. Democritus was one of the first to think that everything was made of particles. As he looked at a pile of sand, he could see it was made of grains. Democritus thought that if you could look close up and actually see inside any substance, you'd find that it too was made of tiny particles. If you take a piece of cheese and cut it in half and then in half again and keep on cutting, eventually you'll be left with a tiny grain of cheese. Your knife isn't delicate enough to cut it any further. But Democritus imagined that you could keep on cutting. He decided that you would eventually get to a point beyond which it couldn't be divided anymore. Atomos is Greek for not cuttable, so Democritus called the smallest unit of matter the atom. Back then, he had no way of proving whether atoms existed, but today, high-tech machines allow us to see them. A layer of aluminium gives this CD its silvery sheen. But at greater and greater magnification, it looks quite different. Keep on magnifying the image thousands and thousands of times, and eventually you can see the individual aluminium atoms. So, just how small is an atom? Imagine building a pile of CDs as high as you can. Just think how many you would need to build a pile 9 kilometers high, as tall as Mount Everest. Well, that's the same as the number of atoms in the height of just one CD. Nearly 9 million. Diamonds are made of the element carbon. The way the carbon atoms are arranged makes it a very tough material. This element is oxygen. It's normally a gas, but cool it down enough and it becomes a liquid. These are both pure substances. They're elements. But what happens when two elements combine? Heat the diamond and it begins to glow red hot. Drop it into liquid oxygen and it reacts vigorously. What do you think might be happening? It It looks like the diamond is burning away. It's gradually getting smaller and smaller. After just a few seconds, this precious stone, which formed 1,000 million years ago, disappears forever. This graphite rod is also made of carbon atoms. It too reacts violently with liquid oxygen. When two or more elements combine together chemically, they form a compound. Solid carbon and liquid oxygen react to form carbon dioxide. The liquid oxygen is so cold that instead of being a gas, the carbon dioxide is a white solid. This is iron wool. Heat it up and the iron begins to react with oxygen in the air. What will form when the iron and oxygen combine chemically? Why does the iron get heavier? So far, scientists have 100 different elements. They're named after all sorts of things like colours, planets and places, but as a shorthand, scientists use symbols. The letter H for hydrogen, C for carbon, and O for oxygen, but the names and symbols don't always seem to make sense.
Silver's symbol is Ag. Ag comes from its Latin name Argentum, so it's no surprise the place where loads of silver has been found is called Argentina.
One of James Bond's enemies is Goldfinger, and his first name's Auric. It's a bit of a weird name, but it was probably chosen because the symbol for gold is Au.
The Romans called lead plumbum, which is why its chemical symbol is Pb. Before lead was found to be poisonous, it was used for most water pipes, so from the word plumbum, we get plumber.
Sr is a symbol for the element called strontium, named after the town Strontian in Scotland, but I like it because it's the element that makes fireworks red.
Br is a symbol for bromine. Bromine gets its name from the Greek word bromos, which means stench, because bromine stinks.
But most things are a combination of many different elements.
The Amazing Elements Show! Take the elements: nitrogen, oxygen, hydrogen, sulfur, and carbon. Add another 14 or so, put them together, add a little chemical magic, and what do you get? A beautiful bunch of flowers. All living things contain key elements like carbon, oxygen, hydrogen, and nitrogen. But yes, you've guessed it. There's more! Look out for these unusual elements: yttrium, europium, vanadium. Add over 20 more, combine them chemically, and what do you get this time? Hey, it's a television set. Without these elements, there'd be no color red on your TV screen. Okay, so this time most of the elements are metals. Copper, aluminium, iron, titanium, and a whole lot more. Combine them chemically, and it's a car! Well, what do you know? It's a fantastic car. Now then, take the same elements as those for the flowers. Combine them in a slightly different way, and you get an elephant. Yes, there may only be about 100 different elements, but they can combine in all sorts of ways to make all the substances we see around us, even living things.
haven't, sir. What's the hurry?
I haven't done
What's the
nothing.
hurry then? I haven't done nothing.
The fact that everything is made up of elements can even help to solve crimes.
Maybe it's just been. What's in this bag here?
Nothing,
Let's have a
nothing.
look. Let's have a look. What's in the bag?
It's mine.
Yeah, have a look in the bag then. Let me have a look at the bag. You've got nothing to hide,
Although our
have you?
suspect doesn't know it, the police can use science to help match him to the scene of the crime, regardless of what's in his bag.
Zip the bag. Whose are these things?
They're all mine.
What's in there? You don't know what's in there, do you? I'm arresting you on suspicion of theft. You do not have to say anything, but it may harm your defence if you do not mention, when questioned, something you later rely on in court. Now, do you understand that?
Yes.
The broken window can provide some important evidence. Whenever an object impacts on glass, it shatters into thousands of tiny fragments. As this missile hits the window, see how a mist of fine glass particles flies back towards the direction of impact. The same will have happened when our burglar broke in. Tiny pieces of glass will have scattered backwards towards him. They'll have become lodged in his jumper and his hair. The suspect's outer clothing arrives at the forensic lab for examination. It's the job of the forensic scientist to look for evidence. The suspect's jumper is shaken over a large piece of brown paper. Any bits which fall onto the paper are carefully analysed. Looking under an ordinary microscope, you can see tiny fragments of glass. They could be from anywhere. But different panes of glass will have a different chemical makeup. So, to incriminate the suspect, forensics need to find out exactly what elements are in the glass from his jumper. To do that, they use a machine called a scanning electron microscope. A small piece of glass is placed into it. This is what it looks like at bigger and bigger magnification. But these pictures still don't tell you about its chemical composition. Reset the machine and it's able to work out exactly what elements are present and how much of each there is. Each peak represents a different element. The largest peak means that silicon is present. It's like an elemental fingerprint. Compare the sample of glass taken from the jumper with that from the broken window and you can see that they're exactly the same. Because every material has its own elemental fingerprint, forensic scientists are able to play an important role in solving a whole range of crimes.
The relevance of elements is elephants. But like elephants, the elements are everything to you.